Hi, welcome back. So for today's videos, I will discuss with you about how to reduce the control system architecture. We have several blocks, and then how we're going to reduce into only a single block. So let's take a look.
Previously, we only have one single block diagram, which is inside we have controller, we have actuators, and then we have sensors. Okay, so in this chapter, we focus on how to identify the block diagram of the systems, and then how we're going to get its transfer functions, and then how we're going to simplify block diagram using two methods. Okay, so one is a block diagram reduction, one is a SFGs. So previously in first chapters, I have introduced to you a system with a block diagram. Okay, so for today I will discuss about the block diagram reduction method. Reduction method, we go back to the basic systems. We have a GS. Previously we have one control systems block, we have a GS, we represent as a GS. Okay, we know the transfer function for this one, so of course the transfer function will be a denominator with nominators. Okay, the output and the inputs form. Okay, in the block diagram, so the important element other than blocks is the signals. Okay, the pulse of the signals, the vector of the signals. So which way the signals will go from or to the block diagram, or to other block diagram, or from other block diagram. That one you need to identify when you simplify the block diagram. Okay, the two elements that needs to be focused in block diagram simplifications is one is a summing junction, and another one is a peak off point. Okay, this thing is almost similar to the circuits, electrical circuits, because electrical circuits have a node. Okay, the splitter, the node splitter, or the node the summing node for the current. Okay, so for the block diagram, they also have a summing junction, summing point, and the peak off point. Okay, the splitting point. Okay, so another one is the form of the block diagram. Okay, we have three basics form in the block diagram, which is we have a cascade like this, which is they have a kind of train of the blocks. Okay, side by side. Okay, in series. So we can simplify this block, just multiply the whole blocks as one, like this. Okay, this is how we simplify the cascade form. So how about the another one, parallel form, which is they have a summing junction here. Okay, summing junction here. So how we going to simplify that? We either sum the blocks, or we minus the block, depends on the operation inside or operation notify here. Okay, so we need to follow the operation that notify on the summing junction. Okay, another one is the feedback form. Okay, so feedback form, which is in the closed loop block diagram form. Okay, in the closed loop control system form. Okay, that one is a feedback form. Okay, feedback is another name for the closed loop. Okay, so when comes to this situation, the first thing we need to check, we need to identify is the simplest form as previous form, which is parallel form and cascade form. So which is for this one is a cascade block. We have two cascade block here. Okay, So this cascade block is simplified into single block at first, like this. Okay, and then you go to the closed loop or feedback form equations, or form of a block diagram, the single block diagram. So the single block diagram for the feedback form, they should have this equation inside the box. I can describe here. For ES is a summation of the RS and the CS HS. Okay, why the minus is here? Because here we doing the feedback. Okay, when it comes to feedback, and also depends on the operation here, but normally here is a negative for the feedback for the closed loop control. This operation, okay, in the summing junction, this one is a summing junction, and this one is a pick off point. Okay, so for the first equation that we can derive for the ES, okay, ES comma RS minus CS multiplied by HS. Okay, for the CS itself, so we have a ES multiplied with GS. Okay, so from here we can manipulate, because our goal is to relate between input and output. Okay, because here we need to have the form of CS over RS equation, because this one is a transfer function. Okay, so that's why they come up with this equation. They make a kind of substituting, okay, and then they can get the CS over RS equation, which is this one is a transfer function for the closed loop or feedback form. Okay, so when we get the final block, then we can get the final equation for the this closed loop or feedback form. So now we go straight to the example. So let's say we have these situations. As you can see, the first step you need to simplify is the simple form, which is you need to search for the cascade form, you need to search for the parallel form. So simplify that one first, and then when you did simplify that one, you will, by the end at least, you will find the closed loop or feedback form. Okay, so afterwards you go to the next step to arrange this block into the feedback form equations, like this one. Okay, so for this block, alright, so actually we have a table for this for your reference, to simplify by using the block diagram reduction or BDR method. Okay, like combining block cascade that we just done just now. Okay, and moving the summing point. Okay, moving the pick off point. Okay, playing around moving that point. Okay, you need to know how you're going to use this table in your situation that you get this summing point adjustment. Okay, let's say we get summing point like this, we can adjust to the summing point to the front. Okay, okay, in condition that you need to have these two blocks in two situations, which is input and as a feedback out input also. Okay, so they have the two here and the output is out here. Okay, okay, this is some examples that I can say for the pick off point. For this case, it's pick off point behind the block. Just now pick off point as a head point for the blocks. So this is how we adjust the block. Okay, so let's say we go to an example here. Obviously we can see the summing point. Okay, and then the pick off point will be here. and they have a cascade form here, right? It's a cascade, it's a summing point, and then this one is a pickoff point. Okay, this cascade form, this one is a summing junction or summing form. Okay, and then they have a GS here as an input before RS. Is after after RS we have another control system block here. Okay, so we go one by one. So let's say we have this summing point, so simplify this one first, then we can get this block, and then we identify this cascade form, we simplify like this, and then at these situations we have a feedback form or closed loop form. Okay, so we go back to the closed loop form equations, so then we can get this single block or single equations like this. Okay, according to the formula for the feedback form. Okay, right, we go straight to the next example, which is more junction. More maybe for you for the first time is quite difficult, because we have junction here, we have summing point the middle, kind of middle of nowhere here. Okay, and here also. Okay, so how are we going to do? So first steps, find the simpler form at first. Okay, for this case we have a closed loop as the simplest form for this front part. Okay, this one the simplest form. Okay, and then we simplify this one G2, and then we can get like this one. Okay, here the summing point, the summing junction is still here. Okay, so in our mind we try to eliminate the summing junction and the pickoff point as much as possible. Okay, that's our target. Okay, so the next step, we try to find the most simpler to simplify some part by using the table. Okay, to ensure that that one can be adjusted. Like this one, we adjust the summing junction to the back of the G1. Okay, because here when we adjust to the back, and then we can multiply G1 with G2. Okay, and then we straightly multiply with the G2. Okay, and the G1 at the below, so is 1 over G1, so 1 over G1 multiply with the H2, so they become H2 over G1 like this. Okay, so next we still want to simplify this G2 because quite bothering having these two pickoff point. The next step, we search the other blocks that we can simply simplify. Okay, the very obvious is this block, these two blocks. Okay, we just multiply these two, and then these two blocks. Okay, this two block is actually as you can see here, is actually this summing junction is actually as a one junction. Okay, is actually as a one junction only. Okay, so that's why here we can just summing these two feedback block, and then one pick off point here and one summing junction here. Okay, so this summing junction and pick off point is actually a closed loop form. So a closed loop form, you need to use the closed loop formula to simplify this block. And then last but not least, we can get this. We just multiply these two blocks and then we can get the final equation for the whole systems of this example.
That's all for this video, so keep watching. We have another video for the SFG, so hope you stay tuned with my channel. Don't forget to subscribe and share this video. Thank you very much.